Adiabatic demagnetization of paramagnetic salts in the production of ultra-cold gases for quantum computing. This midterm paper mainly focuses on the adiabatic demagnetization of some paramagnetic salts, although the applications of the quantum computing with the adiabatic demagnetization are also discussed. First introduced by Peter Debye and William Francis Drake in 1920s, this involves the removal and applying of magnetic field to certain materials, which results in the change in temperature of the materials. So this mainly involves the magnetic caloric effect. Magnetic caloric materials are placed in the magnetic field and it is removed to cool down and is applied to heat up. So this can be repeated to achieve even lower temperatures because when reducing magnetic field it causes the magnetic moments to disorder and cool the material. So one of the applications are quantum computing, but there are other applications as well such as MRI machines in particle accelerators, liquid helium, superconducting magnets, and to study magnetic materials as well. So before we delve into quantum computing, we need to differentiate the classical computing and quantum computing. Classical computers involve 1 or 0 in the information system. However, in quantum computing, it exists in a superposition state representing both 0 and 1. So this property of superposition allows quantum computers to compute so many data and information within seconds compared to classical computing. So because quantum computing needs to be processed in very low temperature, the quantum states has to be in very low temperature to be maintained because it involves qubits. Qubits are extremely sensitive to environmental disturbances and thermal fluctuations. So it has to be maintained at very low temperature. So therefore we need a very suitable low temperature method that needs to be applied. So that would be adiabatic demagnetization. So applications of quantum computing are to revolutionize cryptography and simulating quantum systems and exponentially increased computation power compared to classical computers. So adiabatic demagnetization mainly does 4 procedures. First, it is a cooling technique to attain very low temperatures, absolute zero. It relies on magnetic properties of the materials, and there are few techniques so that we can achieve the low temperature methods. So in this term paper, there will be discussion on salt filled method. Um, Moving on, there are other cooling techniques as well, such as dilution refrigerator, magnetic refrigeration, laser cooling, nuclear demagnetization, which is slightly different from adiabatic demagnetization. So this picture shows how laser cooling works. So the methodology in few papers that was obtained was using salt pill method. So in this paper, ferric ammonium alum, which is a paramagnetic compound, was used for the as a magnetic caloric effect. This is the design of how the salt pill method is done. So the same sample chamber houses the ferric aluminum alum. So with this size and with this geometry, it's very effective to decrease the temperature of the material. And this picture also shows the real apparatus of the salt pill method. And other paramagnetic also can be used. There are many other paramagnetics such as yttrium, alloys, and other metals also can be tested for salt pill method. So, salt pill method successfully constructed with a vacuum sealed container and fabrication of paramagnetic salt pill for adiabatic demagnetization. So the salt pill containers are durable and dependable, with some still function even after 4 years. And comparison of demagnetization process between conventional localized moment refrigeration and high entropy itinerant moment refrigeration. So the cooling curves can be are obtained as can be seen in the paper by integrating the magnetic cooling effect, which is magnetic caloric effect as well, with the magnetic field applied parallel to the 100 direction. So because paramagnetic materials are salts and can be in different direction with its crystalline property, the direction of the applied magnetic field is also important. So in conclusion, the study focuses on ADRs, demagnetizing refrigerators, and these paramagnetic material, different paramagnetic material are obtained, are used, and low temperature are obtained up to millikelvin scale. So therefore, it can be used in quantum computing. Thank you.